हेलो। हेलो बच्चों, आवाज आ रही है मेरी? लेट्स सी।
आवाज आ रही है मेरी?
एकदम बढ़िया आ रही है। गुड। दिख नहीं रहा हूँ क्या यार? हाँ, नमस्कार, आदाब, सत श्री अकाल। कैसे हो बच्चों? हाउ आर यू ऑल? आई होप दैट ऑल ऑफ यू आर डूइंग वेरी गुड in your studies. So till now what we have studied in the first lecture and first part of modern physics, majorly we have seen the interlink between the optics part and the modern physics. What is the difference? What we are going to study about that debate, very interesting thing about light that we have started in the last lecture, and that is what we are carrying on in this one. Okay, so we have understood about that how we are going to proceed in this chapter. Basically, we are going to prove that light is having a particle nature also. Till now we were proving it by what experiment? By an experiment of Hertz that he have did, and it was photoelectric effect. And we have seen about photoelectric emission, how that is happening, what is really the kinetic energy. Maximum kinetic energy is equals to energy of the incident photon minus of work function. This was the formula of it, was actually Einstein's observation. What further Einstein have observed? He have observed about the threshold frequency. Threshold frequency was a very important thing. Then he have observed about threshold wavelength. Both these definitions very important that we have seen. Then we have seen curve between kinetic energy versus frequency, kinetic energy versus 1 by wavelength. All these things we have studied in the we have seen about work function. What is work function? It is the minimum energy required for any electron to come out of the surface of the metal surface that is present there. Okay, these things we have already discussed. Now let's move to the little bit next portion. Okay, let's see about some variations, important variations about that same photoelectric experiment that we have understood. In the same experiment, let's see what further we have to understand. Okay, so let's understand, start from here. What is first thing is, in same photoelectric experiment, I've told you this is called as collector plate, this is called as emitter plate. If I will quickly recap you for the what we have understood, this was called as collector plate. What was happening here? If light is coming from here, light rays are coming from here, and if I will say that this light ray or the frequency is greater than the threshold frequency, then what will be happening? This light is sufficient to perform photoelectric effect. Photoelectric effect, if it is sufficient to perform, then what will be happening? This light will be incident on this emitter plate. Here free electrons are available. This is negative charge and this is positively charged. What will be happening? Light will be falling here, electrons will be absorbing, taking that energy, and that energy is coming in form of photons that we have what studied, and that those electrons will be emitted out of the surface. Those electrons will be emitted out of the surface. Now this is negative charge, here it is positive, there will be attraction normally. That means these electrons, and these electrons were named as, what was the name that you have given for these electrons? These electrons were called as photoelectrons. These electrons were called as what? Photoelectrons. Now obviously there will be a normal attraction also, but we have attached a variable source also. Due to that also some potential difference will be coming. Potential difference से electric field आएगा, electric field से force of attraction आएगा, and due to that also there will be some, we will discuss. As of now I'm just telling you about the simple setup. So this will be attracted and electrons will be started traveling. If electrons are started traveling, a current will be generated in the circuit, and that current will be what? Called as photocurrent. That current is called as what? Photocurrent. Okay, photocurrent will start flowing into the circuit. Simple thing. That till now what we have understood. Now what will be the effect of intensity of light? Let's suppose I am increasing the intensity of light from the torch or whatever it is there. I am increasing the intensity of light. What is the meaning of increasing the intensity of light? Increasing intensity of light means I am increasing the number of photons that is incidenting here. If number of photons is increasing, can I say more electrons will have more energy? Correct. Let's suppose as of now I am throwing 5 balls. For example, I am standing on a roof. Okay, and in downward area, let's suppose 100 children are playing. Okay, I am throwing initially 5 balls. That means only 5 kids can take those balls and they will start playing. correct? But let's suppose all of a sudden I have increased my intensity, and now I'm increasing the intensity and I'm now throwing 10 balls at a time. Now what will be happening? At the same time, 10 kids will be taking that ball and they will be starting playing with that, correct? I am getting blurred or my video is getting blurred? Yeah. Okay. So in this way, if I am increasing the intensity, what is happening? More and more electrons will be coming out. If more and more number of electrons are coming out, that means number of photo electrons traveling will be increasing. If number of photo electrons, that means more number of electrons will be traveling. That means, can you say my current will be increasing? My current will be increasing. Exactly, that is what the effect of increasing the intensity. Increasing intensity, number of photon electrons will be increasing, that will be coming out of the surface. If more number of electrons are coming out of the surface, I can say simply my current is also going to increase. That is what here it is explained. When suitable, obviously there should be a minimum frequency, that is the threshold frequency have to be there. Now see, the photoelectrons are emitted from it which accelerated towards the anode. These electrons flow in the outer circuit. It is called as photocurrent. Due to this microampere, there will be some deflection here in current. Microampere current will be flowing, correct? So see here, as the intensity of light increases, as you are increasing the intensity of the light, number of photons incident per second also increases. Number of photons that is getting incident per second will also get increases, due to which the photoelectrons emitted per second also increases, hence the photocurrent also increases. So if we are plotting a curve between photocurrent and intensity, what will be happening? As intensity is increasing, you can say photocurrent is also increasing. Very obvious thing that will be happening, okay? Not a rocket science. But after a certain time, when all the electrons have been emitted, all the electrons have been emitted from the anode side, and all the cathode from the cathode side, and they have reached to the anode side, then what will be happening? Then a saturation level will be coming. Then further the current will not be increasing. It is not like that current will be increasing till infinite time. It is not the case. Current will increase to up to certain limit, until unless not all the electrons are coming out of that cathode plate that is present there, and after a certain time it will attain a saturation level. Saturation level means it will become stagnant. Now current will not further increasing. Okay, this is the simple meaning. So here you can see when all photoelectrons reach plate A, all the photoelectrons that were present here, they've reached to plate A. Current reaches its maximum value is called as saturation current. The maximum value of current is called as saturation current, and it will be represented like this. So in net it is represented, firstly it will be increasing function, then it will be attaining its nearly saturation level. That means a kind of straight line it will be attaining, correct? Now the next thing is effect of potential. Now what will be the effect of potential? Now let's take some deep dive into it. What I am going to tell you, let's understand now. See, understand here what I am trying to tell you. This x-axis is representing potential, and this y-axis is representing current. This x-axis is representing what? Potential, and y-axis is representing current. This is the variation that we have to understand. Now, firstly, let's understand the positive side. Let's suppose potential is positive. Potential is positive, that means this kind of natural battery is connected. This will be negative side and this will be positive side. Anode will be at positive and cathode will be at negative, correct? Okay. And already this was negative, and this is negative potential connected with it, and this is a higher potential connected with this will be the higher potential, and this will be the lower potential. Okay. Now you know, tell me, what is the direction of electric field? If potential difference is present, obviously there is some electric field will be coming, correct? Because E is equals to V into D, we can write. That is a relation that we have studied in electrostatics. Now tell me, what will be the direction? Batao, kya the direction? Remember, the direction for electric field is always from higher potential to lower potential. That means what I can say, electric field will be traveling from higher potential to lower potential. Till now we are only analyzing the positive side, we are not entering into the negative side. So understand only when this battery is connected positive. That's what I can say. If electric field is having this direction, what will be the direction of force on the electron? Let's suppose a force, an electron is ejected here. So conventionally the direction of force and electric field are same, but what will be happening, because it is a negative charge, that means force direction will be reversed. Here it will become force is equals to Q into E. Force will be reversed and it will become Q into E. Q into electric field, charge into electric field, correct? So now they will get attracted towards the positive plate. Already there was a normal attraction. Already this is a negative charge and here it is a positive plate. Already there is a sort of attraction there. But now what is happening? Now a force is also acting, and that force is equals to Q into E. Now that extra force will be taking this electron more further with more speed, and the more electrons will be coming towards the anode plate, the more photocurrent will be there. Correct? That means what I can say about the effect, if you are increasing this potential, if you are increasing this potential difference, what will be happening? Here it will be V potential, here it will be zero potential. V potential, zero potential. The potential difference is increasing. Potential difference is increasing. What I will say? Electric field is increasing. Electric field is increasing. What I can say? That force is also increasing. If force is increasing, that means what I can say? Electrons, more and more electrons will be traveling to the collector plate. Correct? That means what kind of curve I will get? I will get an increasing curve. This is the saturation level. After a certain time, when all the photoelectrons will be coming, then there is no electron, then what will be doing? It will be a saturation level. But the interesting case is the second one, that is a stopping potential case. Let's suppose you have reversed this. Negative potential means what? You have reversed the battery. Now let's understand here. In this diagram only, let's understand. Now what you have did, you have reversed this scenario. Okay, understand this. That is more interesting. You have reversed this scenario. This was the higher potential, this was the lower potential. Now, but you have made it higher potential, and this have been made lower potential. This have been made lower potential. That means now you have connected it negatively. So I can say this is at potential V and this is at potential 0. Let's suppose the potential here battery EMF is V. That means potential difference is one potential will be at V, second potential will be at 0. Correct? Now tell me what is the direction of electric field that you will be having. Already I have told you now what is the direction for electric field. Always from higher potential to lower potential. Take it from higher potential to lower potential. Higher potential to lower potential. This will be the direction for electric field. Correct? Now let's analyze what will be happening with that electron that was emitted here. You will be saying, sir, electric field is having this direction. That means force will having the opposite direction. Exactly. Force will having the opposite direction. Now what will happen? Electron will try to go towards the positive plate, because anode is basically what? A positive plate. But this extra force will not allow, because the force is taking this only on the same side. That means it will not allow this electron to reach at the cathode plate. If electrons are not able to reach at the cathode plate, how the current can come? How the current can be generated? Slowly, if you are increasing this potential difference, that means this force is also getting stronger. If this force is also getting stronger, it will not allow a single electron to pass through the to reach the collector plate. If not a single electron is not reaching the collector plate, how the current will be coming? So what is the definition of stopping potential? Now understand. Now see here. What is potential? Negative potential. Here it is represented. This is the curve. Okay. As soon as it is increasing, it will be fine. That okay, the current will be increasing. As soon as you are increasing the potential, at a certain point, the current will become 0. That point is called as what? Stopping potential, because at that potential, not a single electron will be able to reach at the collector plate. This is what we have to understand. So if you are understanding the definition, here it is given: the negative potential of plate A at which the photocurrent becomes 0 is called as stopping potential. Okay, this is what the definition of stopping potential. Important thing I will say, better if you are reviewing for board perspective also and the competitive perspective also, you should be knowing about stopping potential. Now how the equation is written, let's understand. The equation is written like this. If you remember, work done was written how the energy was defined as. It was defined as, if potential difference is given, energy was defined as Q into delta V. Here kinetic energy is the we are going to define in the same way. See how. Normally, what is the equation that you have learned? Kinetic energy. Let's take some different. What you have learned? Kinetic energy is equal to energy of the incident photon minus of work function. This is what you have seen the observation of Einstein. So now what we are going to write, we are going to write kinetic energy in some different term. I am going to write E into delta V, that is a potential difference, and I am going to write here to find the stopping potential. I will write Vs is equals to energy of incident photon, that means h mu minus of h mu naught. That means what I can say about stopping potential, it will be equals to h mu by E minus h mu naught divided by E. This is what I will be writing for the stopping potential. This is what I will be writing for the stopping potential. Now it can be, it depends on the question. If it is written in terms of lambda, you know that how to manage that. At the place of frequency, you will be writing what about wavelength. Correct? Very good. Now there are some important curves are there, that how the variations are coming. So now let's try to understand. Before this, understand this one, then it will be more easier for you to understand the last one. See, what is the you have to check the variation of what effect of frequency on stopping potential. Here what is the first, always in this kind of cases, always try to understand about what relation we are trying to relate to, which kind of quantities we want to relate. What is the relation that I can write between them? So here the relation is between photocurrent and the potential. Photocurrent and the potential. And what we are doing, we are changing the frequency. Let's suppose three lights are incident here. First one is mu1, second one is mu2, and the third one is mu3. Okay. And here it is also written that mu3 is greater than mu2 greater than mu1. This is the relation that is given. Okay. Now see what will be happening. If it is the case, then write the relation. What you will be writing? E into stopping potential is equals to, in terms of mu, what you write the equation, it is h mu minus of h mu naught. That means what you can write for stopping potential is equals to h mu divided by E minus of h mu naught divided by E. Correct? Now observe one thing. What will be happening if you are increasing this frequency? If you are keeping increasing this frequency, who is having the highest frequency? Mu3. Mu3 is having the highest frequency. So if this value is greater, can I say this value is greater? If this value is greater, can I say this stopping potential is also going to be greater? Yes or no? Yes or no? Simply, if I'm increasing this value, this stopping potential will also be increasing. So I can say if this is Vs3, this is Vs2, and this is Vs1, who will be higher? Obviously that stopping potential 3 will be higher because it is having the highest frequency, then stopping potential 2, then stopping potential 1. This will be the scenario. So you already know that firstly current will be increasing, and then finally it will be attaining its saturation level. So saturation level will be same because current will be same. By changing the frequency, it is not going to affect the current. Correct? But it is going to affect directly. Here you can see there is a direct relation of stopping potential and frequency. It is directly going to relate the stopping potential. It is going to impact the stopping potential. Okay. Now let's understand the last one. This curve is very important. Okay. Now understand this variation. What variation here it is coming? See. Effect of potential on photoelectric current. Effect of potential. If you are increasing the intensity, I have already told you, increasing the intensity means what? You are increasing the number of photoelectrons. That means increasing intensity, that means number of photon is increasing. Number of photon is increasing, that means the more number of photons are going to hit, that means more number of electrons are going to come. If more number of electrons are going to come, the more current will be flowing into the circuit. Okay. So if you are writing this equation, if you are writing the kinetic energy equation or stopping potential equation, how you will be writing that? It will be h mu divided by E minus of h mu naught divided by E. Correct? Now tell me, at any single place, is frequency, its intensity term or the number of photons is going to affect the stopping potential? Can you say any relation between stopping potential and number of photons? No, there is not any direct relation. So I can say stopping potential will not be changed, it will be same, but it will impact the current because again and again we are saying by Fata voice speaker, okay, that it is, if intensity is increasing, number of photons is increasing. If number of photons is increasing, the more number of photons going to hit, that means more number of electrons are going to come out of the surface. That means more photoelectrons are coming in, that means more the more current will be coming. See here, if I3 is greater than I2 greater than I1, now I that this is given for intensity, this will be the curve. Current I3 will be highest, then I2, then I1. Now I don't know for it is intensity, you can take it for intensity distribution. If it is intensity distribution, this will be the curve for I3 intensity 3, this will be the curve for intensity 2, this will be the curve for intensity 1. Correct? Clear? आया नहीं आया यार? आया? Is there any lag or fine? I hope that it is fine. समझ आया इतना दूर तक? Now after that again the curves. Curves are the most easier things. Okay. What about just find the relation and see what is you have to plot. Stopping potential versus frequency. कर देते हैं यार plot. क्या ही दिक्कत है? There is no rocket science. What you have to plot is stopping potential versus frequency graph. लिखो equation firstly. Stopping potential versus frequency. What is the relation that you write? Stopping potential Vs is equals to h mu, that is the frequency, divided by E minus of h mu naught divided by E. This is what the relation that you write. Now with what you have to put the relation stopping potential versus frequency. This is what you have to write. That is stopping potential is at y-axis, y is equals to this will be form of m into x. X is frequency minus of some c. That means what are the two things that you are going to get from here? Slope you are going to get from by it is equals to h by e, that is positive, and intercept is negative, that is equals to h mu naught by e. These are the two things that you can take from here. This hitting point is nothing but equals to h mu by e, that is also can be written as work function by e. And what is the slope that you will be writing for this is it is equals to h by e. Correct? Last class also we have plotted some curve, so this is now we are getting familiar with. Not the first time we are plotting. One more plot you have to do. See, now you can plot any kind of curve, no problem. Now see, what is the question? Question पढ़ो. See, the photoelectric threshold wavelength. क्या लिखा है? Photoelectric threshold wavelength of a silver is इतना 3250 into 10 power minus of 10 meter. Very good, thank you. आगे क्या लिखा है? The velocity of the electron ejected from silver वेवलेंथ दे रखा है ऑफ द इंसिडेंट फोटोन. कितना दे रखा है? इतना दे रखा है. इतना कितना? 2536 into 10 power minus of 10 मीटर. ये दोनों वेवलेंथ दे रखा है. नाउ व्हाट द क्वेश्चन इज आस्किंग यू, ये भी देख लेते हैं. h भी दे रखा है, c भी दे रखा है, एंड व्हाट द क्वेश्चन इज आस्किंग यू, पता नहीं यार क्या पूछ रहा है. द वेलोसिटी ऑफ द इलेक्ट्रॉन इजेक्टेड, ये पूछ रखा है. वेलोसिटी ऑफ द इलेक्ट्रॉन इजेक्टेड कैसे लिखोगे इक्वेशन? यू नो दैट काइनेटिक एनर्जी मैक्सिमम इज इक्वल टू कितना लिखते हो बच्चों? You write it as hc divided by lambda incident minus of hc divided by lambda naught, and here what we'll be writing, half mv square is equals to this velocity. ये velocity you have to calculate. It is equals to hc को ले लो common और hc को लिख लो. I will say in terms of electron volts लिखोगे तो better होगा. वो directly लिख लो 12400 and यहाँ बच जाएगा तुम्हारे लिए incident is 2536 minus of 1/3250. भैया कर लेना. ओके, जब सॉल्व कर लोगे तो आ जाएगा तुम्हारे पास वेलोसिटी. पहले बोला था क्वेश्चन तो आसान होंगे, फंसोगे कहाँ ये कैलकुलेशंस में कभी कभी. ओके, वो भी हमेशा नहीं, कभी कभी ऐसा बुरे कैलकुलेशंस आ जाते हैं. तो I just have to tell you that what kind of calculations you can have, so that's why I was making you prepare. करेक्ट, गंदा कैलकुलेशन है. आंसर बता देता हूँ, आंसर इज ऑप्शन डी, तो क्रॉस चेक कर लेना. ओके, नेक्स्ट क्वेश्चन पढ़ो. नीट 2017. इफ फोटो इलेक्ट्रिक एमिशन फ्रॉम अ मेटल वर्क फंक्शन. हमेशा जब भी क्वेश्चन पढ़ो लिख लो वर्क फंक्शन दे रखा है, कितना दे रखा है, इतना दे रखा है, इतना कितना 1.8 इलेक्ट्रॉन वोल्ट्स. आगे बढ़ते हैं. द काइनेटिक एनर्जी ऑफ मोस्ट एनर्जेटिक इलेक्ट्रॉन. काइनेटिक एनर्जी दे रखा है, कितना दे रखा है, इतना दे रखा है, इतना कितना 0.5 इलेक्ट्रॉन वोल्ट. डन. और कुछ दे रखा है, क्या देखा है? द कॉरस्पॉन्डिंग स्टॉपिंग पोटेंशियल. अरे तो लूसा सवाल है यार. स्टॉपिंग पोटेंशियल कैसे लिखते हो यार? E इंटू स्टॉपिंग पोटेंशियल, ई कैंसिल. स्टॉपिंग पोटेंशियल इज इक्वल टू 0.5 वोल्ट. खत्म. ऑप्शन सी, डन। हो गया, हो गया, खुश हो गए? यही था, समझ आया? सो दिस वाज अबाउट फोटो इलेक्ट्रिक इफेक्ट। ओके, ये एक्सपेरिमेंट, कंप्लीट एक्सपेरिमेंट दैट प्रूव्स दैट लाइट इज हैविंग सम सॉर्ट ऑफ पार्टिकल नेचर, सम सॉर्ट ऑफ पार्टिकल नेचर। दैट मीन्स ऐसा नहीं बोल सकते हो कि लाइट हमेशा वेव में। तो अब एंटर करते हैं भैया, हो गया भैया, पार्टिकल बोल रहे हो, कभी वेव बोल रहे हो, बता भी दो कि क्या बोलना है। तो नाउ एंटर द डी ब्रोगली हाइपोथेसिस। द डी ब्रोगली scientist was there who have given the concept of dual nature. Dual nature means light will be behaving like a particle also, light will be behaving like wave also in different scenarios. At a single time it cannot behave like both particle and wave. In different time, different behavior it can have. Okay, this is what was concluded. So now some basic things that you have to study, ये पढ़ लें। लुइस वेक्टर डी ब्रोगली, ये उनका पूरा नाम था जिनके बारे में तुम जानते हो हमेशा से। Put it forward a hypothesis that moving particle of a matter should display wave-like properties under suitable conditions. The wave associated with the moving particles are called as matter waves or de Broglie waves. The wavelength associated with the moving particle is known as de Broglie wavelength. The moving particle that is the moving particle जो है उसको क्या बोलते हैं? उसके साथ जो associated wavelength है, that wavelength is called as what? De Broglie wavelength. I will tell you in what scenario it is called as wave nature. See, natures are dominated. Sometimes wave nature will be dominated, sometimes particle nature will be dominated. Now in different conditions they will be dominated. Okay. As of now, he have given that de Broglie wavelength, he have explained, and how much he have explained the de Broglie wavelength, it was equals to h by p. What is p? H is Max Planck's constant, p is what? Momentum. So it can further be written as lambda is equals to h divided by mv. H divided by mv. Further it can be written as what? H divided by momentum can be written as root under 2m kinetic energy. 2m kinetic. All these are formulas. All these are formulas to solve wavelength, different scenarios. Let's suppose if it is the asking you the relation between kinetic energy and the other thing, this is the relation that you are going to use. Now how further it can be written as h divided by root under 2m. Kinetic energy can also be written as q into delta v. चार्ज इंटू पोटेंशियल डिफरेंस भी लिख सकते हैं इस फॉर्मूला को। और कैसे लिख सकते हैं इस फॉर्मूला को? लिख सकते हैं जब सारा वैल्यूज पुट करोगे और इलेक्ट्रॉन्स के लिए कैलकुलेट करोगे। व्हेन यू आर कैलकुलेटिंग दिस फॉर इलेक्ट्रॉन, you are putting the value of h, though in general it can also be written as 150 divided by v in electron volts, और ये जो आंसर आएगा ये तुम्हारा एंगस्ट्रॉम में आंसर आएगा। ओके, द आंसर विल बी कमिंग इन टर्म्स ऑफ एंगस्ट्रॉम। तो इतने तरीकों से तुम अपने आंसर को लिख सकते हो, different सिनेरियोज। अब डिपेंड करता है क्वेश्चन पे कि व्हाट द क्वेश्चन इज गोइंग टू गिव यू। ओके, सी H can be written as 2mqv. I have told you that kinetic energy को कैसे लिख सकते, जस्ट अभी तो लिखा था स्टॉपिंग पोटेंशियल के टर्म में। So and when you are putting all these values, finally क्या लिख सकते हो? और भी lambda is equals to 1.27 divided by root under v, and this value will be coming in angstrom. This value will be coming in angstrom. Okay. तो इसी के बेसिस पे एक सवाल भी कर लेते हैं। इजी है यार, मैटर वेव्स इज नथिंग। Let's see what is the question. An electron is associated accelerated from rest through a potential difference v volt. अच्छा, v volt दे रखा है। If the de Broglie wavelength of the electrons, de Broglie wavelength दे रखा है। अच्छा, कितना दे रखा है? इतना दे रखा है। इतना कितना दे रखा है? इतना। हाँ, de Broglie wavelength, चलो लिख लिया। और क्या दे रखा है? The potential difference is, potential difference you have to calculate. कैसे कैलकुलेट करेंगे potential difference? Simply I can say potential difference for electron you want to calculate. चलो तलवार, क्या कर सकते हो? मुझे तो नहीं आ रहा है, तुम बता दो क्या है। 1.227 into 10 power minus of 2, and this is what? Nanometer. And here what you can write, you know, I have told you recently a formula that it is equals to 12.27 divided by this is de Broglie wavelength root under v, that was in angstrom. Okay, हाँ यार, वहां पे इलेक्ट्रॉन वोल्ट मत कर लेना यार, you have to write in terms of volt only, not electron volt. Okay, अगर if by mistake I have written, तो change it last slide. Okay. तो यहाँ पे क्या करोगे? This is what but you have to write in terms of angstrom. Angstrom में लिखना है तो इसको लिखोगे 10 power minus of 3. Now it is written in terms of angstrom. It is equals to, this is the de Broglie wavelength. It is, can be written as 12.27 divided by root under V. Now take it here, take it down. Then what will be happening? If I am writing it here, it will be 0.12. कितना हो जाएगा यार? 12.27 to 10 power minus of 2. 1.27. इसको ढंग से कैलकुलेट कर लो यार. Let's calculate it properly. How it can be written as ये तो सही लिखा है ना, in terms of angstrom. If you want to convert in terms from nanometer to, correct. So when you are taking this downward, correct. So you will be writing what? Root under V is equals to 12.27 divided by 1.227 into 10 power minus of 3. अरे कैसा चूजा जैसा सवाल है यार. तो क्या लिखोगे? रूट अंडर v इज इक्वल्स टू 10 पावर 2. कर लो सॉल्व भैया. तो v विल बी इक्वल्स टू हमारा 10 पावर 4 वोल्ट आएगा. कितना होगा आंसर? डी ऑप्शन. समझ आया नहीं आया? कॉन्सेप्ट इज इजी. ओके, एक ही काइंड ऑफ फॉर्मूला है जो हमेशा यूज करना है फॉर डी ब्रॉगली वेवलेंथ. हाँ करेक्ट. देन यू विल बी सॉल्विंग दिस, यू विल बी हैविंग दिस आंसर. करेक्ट. उसको कन्वर्ट कर लेना उस फॉर्म में, एंगस्ट्रॉम में करेक्टली, तो यू विल बी हैविंग योर आंसर. नाउ द नेक्स्ट वन. The de Broglie wavelength of a neutron in thermal equilibrium with heavy water at a temperature T Kelvin and the mass is m. What will be the de Broglie wavelength? Okay, de Broglie wavelength लिखना है at a temperature. तो कैसे लिखोगे? H divided by root under 2m into kinetic energy that we write. Okay, this is also one form of de Broglie wavelength. तो क्या कर सकते हैं? H divided by root under 2m into kinetic energy. Kinetic energy can be written as law of equipartition, अगर याद हो, F by 2 into kT. किसके टर्म्स में? kT के टर्म्स में ये दे रखा है. Now you are writing for a neutron. For a neutron, the degree of freedom will be 3 by 2 into kT. Now just put it here. You will be writing 3 by 2 into kT. 2 cancel. Answer will be H divided by root under 3m kT. कौन सा आंसर सही आ रहा है भाई? ऑप्शन ए विल बी कमिंग करेक्ट. चेक कर लेते हैं. ऑप्शन ए विल बी कमिंग करेक्ट. समझ आया? इज इट क्लियर? नाउ कम that dual nature, about more, little bit more discussion about the dual nature, when the wave nature is dominated, when the particle nature is dominated. Let's come to more discussion about that. Here it is very beautifully taken two cases. I will explain you everything from these two cases. Here is a taken a baseball on one side, that is also spherical body, and on the other side I have taken a electron, that is also a spherical body. Size is different. Mass is given as 138 gram and speed that it is having is 30 meter per second. Still 30 meter per second is very high speed, I am telling you. So when you will be calculating de Broglie wavelength or the wavelength, it will be coming 1.6 into 10 power minus of 34 meter. Minus of 34 meter. That is very small value. And here if you are calculating the wavelength, here what will be having wavelength? Mass is what? 9.1 into 10 power minus of 31 kg. Speed is what? 3 into 10 power 6 into meter per second. तो जब यहाँ पे निकालोगे वेलोसिटी, यहाँ पे गलत लिखा है यार, 3 into 10 power 8 meter per second. So when you will be calculating the wavelength, you will be having 2.42 into 10 power minus 9. That is little bit fine. Okay, in terms of meter we are calculating. So what is the conclusion? For microscopic particle, wave characteristic can be observed. It is performing some wave characteristics for microscopic particles, and for macroscopic particles, wave characteristic cannot be observed. It is very tough because chemistry with Suha sir. Oh, thank you sir, thank you so much. We are missing you all here. I hope that you will be taking raid in my physics class very soon, I hope. As today Suha sir is not there. We all are missing him. So is it clear that when, in what cases you will be? Yes, sir. Miss you too, sir. Miss you too. So in what cases it will be having domination of particle nature? In what case it will be having a domination of wave nature? It should be very clear to your mind. Okay, this is about duality, or that means we take light as both as particle and wave nature. Now let's come to the last portion of, that is radiation pressure. Radiation pressure means what? Let's suppose this is the surface. This is the surface and light is incident on this metal surface. Okay, so I can say if higher intensity of light is incident on this metal surface, some pressure will also be applied, some pressure or will also be applied on this surface. So that pressure is called, we give a term that the term is what? Radiation pressure. That term that we give here, it is what? Radiation pressure. So for radiation pressure, some steps are there that I'm going to tell you from that. Now it's up to you. If you want to directly remember the formula, there is direct formula also, but I am going to tell you the complete basic derivation also, because that is interesting. Okay, so let's see the first case. Here you just have to tell me the change of momentum, because change in momentum is going to be used here. So I will just quickly recap, because बहुत बच्चों को 11th के portions में पेन होता है, तो आई नो कि अगर मैं ये नहीं बताऊंगा तो तुम्हें वैसे भी नहीं आएगा रेडिएशन प्रेशर. सी, लेट्स सपोज कि द बॉल इज गोइंग टू स्टिक विद द सरफेस. कैसे लिखोगे चेंज इन मोमेंटम? आई एम टेलिंग यू. What is the initial momentum? You will write in momentum is always a directional quantity. It is a vector quantity, so you have to mention the direction also. I will be writing the vector m into v. In what direction? In negative direction. I will take conventionally downward direction as negative direction. Final momentum, what I will write? Final momentum I will write is 0. So if someone asks me, better tell me what is change in momentum? Change in momentum I will write p final minus p initial. What is my final momentum? 0. What is my initial momentum? Minus of mv. So what is change in momentum? Change in momentum I will say, sir, it is plus of mv. Plus of mv. Simple. Is it clear? Now let's come to the second one. Here it is hitting the ground or hitting the surface with velocity v and completely reflected with the same velocity v. That means there is no loss of energy. No loss of energy. That is what I can say. Again I will say initial momentum I will say minus of mv. Final momentum I will say plus of mv. If change in momentum I have to calculate, I will say final minus initial. That means mv minus of mv. That means it will net become 2 times of mv. This is the second case. Now let's come to the third case. Third case क्या बोल रहा है भाई, देखते हैं. Now let's suppose at some angle, specific angle you are hitting. In this case what we do, अगर किसी बच्चों को collision याद होगा, collision topic, there we have seen the cases of oblique collision. This is the example of oblique collision. What we do, we take two components. One component will be v cos of theta, one component will be v sin of theta. One component will be what? V cos of theta. Second component will be what? V sin of theta. And now tell me which component is going to hit the surface, v sin theta or v cos theta? Actually, which component is going to hit the surface? It is v cos theta. So whatever the change that is going to come is only for v cos theta. ये component तो hit नहीं कर रहा, तो why it will be change? It will be as it is same. It will be change. So now again it is same. It is reflected back at the same angle, same thing. So initial momentum, what will be saying? In downward direction mv cos theta minus of mv cos theta. Why? Because we are taking the downward direction as negative direction. Final momentum I will be writing m mass into velocity. Velocity is in upward direction, that means mv cos theta, but with a positive sign, because upward direction I am taking conventionally as positive. So what I can say about the change in momentum? Change in momentum I will say simply 2 mv cos of theta. Final minus initial, again we are doing the same thing. इतना क्लियर है? अगर इतना क्लियर है तो बाकी सब भी क्लियर है. ये क्या हुआ भाई? ये क्या हो गया? मुझे लगा हैक वैक हो गया क्या? See, radiation pressure is the pressure experienced by the surface exposed to the radiation. The photons that are incidenting on the surface, the pressure that is created due to that is going to defined as radiation pressure. And you know the pressure formula is conventionally what? Force upon area. Here also we are going to use the same formula. So now let's understand the first case. Understand step by step, one by one. Let's understand. Case 1 is complete absorption. And here absorption coefficient will be 1 and reflection coefficient will be 0. इसी टाइप का एक और टॉपिक है, that is heat transfer. Heat transfer, if anyone remember, heat transfer may be reflection coefficient, transmission coefficient, absorption coefficient, all these three kind of things are coming. Anyways, let's come back to the topic. Now let's understand the first one. Completely absorbed. That means photons are incidenting and they are completely getting absorbed. That means nothing is getting reflected. Fine. We have already seen what will be the momentum. Final moment, initial momentum. Batao, what will be writing the initial momentum? I will be writing sir initial momentum, and here it is defined as intensity. What is intensity? That वो भी बता दो. Power is defined as intensity divided by area. मैं उल्टा बोल दिया यार. उल्टा बोल दिया. उल्टा बोल दिया. सही तुम बता दो. सही तुम बता दो. Intensity is defined as power divided by area. Intensity is defined as what? Power divided by area. Fine. If I have to write momentum, कैसे लिखते हैं momentum? It is equals to h by lambda. So I will write initial momentum. Initial momentum I will write h divided by lambda, and I will write with a negative sign because I am going in downward direction, and conventionally always we take downward direction as negative direction. सही है? Now, what is the final momentum? Final momentum I will say 0 because finally it is going to stick with the surface. What is the change in momentum? Sorry, what is the change in momentum? Final minus initial. Final minus initial, that means h by lambda हो जाएगा. h by lambda, final minus initial बस कर दिया. Now energy incident per unit time. Energy incident per unit time. What is energy per unit time? बता सकते हो? What is energy per unit time? Can you say the same thing? I can say power. Energy per unit time को क्या बोल सकते हैं? Can you say it is nothing but power? So what is power? Power is already here defined. Power is, I can write it is equals to I into A, intensity into area. चलो ये भी हो गया. Now important one is for number of photons incident per unit time. Starting में मैंने I have told you that how to write this thing. Let's again understand. Okay, let's again understand. What you can write energy? You can write it as hc by lambda. क्या लिख सकते हो एनर्जी के लिए? hc by lambda. Fine. But this is the energy for one photon. If I will ask you for n number of photons, what you will be doing? You will be writing it as n. Correct? Okay. Now, if I will ask you to write energy per unit time. Energy per unit time, when you will be writing, you will be writing here by t, and here also you will be writing t. Correct? Divide both the sides with t. Clear? Exactly what I'm asking you, tell me what is the number of photons incident per unit time. Number of photons incident per unit time. Can you say this is what I want to calculate? Correct. एक और चीज notice करना, very important. What is the change in momentum? Change in momentum is what? h by lambda. That means can I say this is h lambda by h. That means I can say it can also be written as n by t divided by change in momentum. Here it is c and here it is, I can say it is nothing but power. Correct? इसको तो power लिख सकते हैं ना, energy by time. तो अब बताओ कि what I can say, this is what I have to calculate. I will say number of photons per unit time is equals to power into change in momentum divided by c. Change in momentum divided by c. Correct? Fine. Now, what is the total change in momentum per unit time? What is the total change in momentum per unit time you have to calculate? कैसे calculate करोगे change in momentum per unit time? And can you say change in momentum per unit time is nothing but force? Force को कैसे define करते हो? Rate of change of momentum dp by dt. कैसे define करते हो? It is equals to dp by dt. कुछ तो गलत किया है यार. यहाँ पे जब लिखोगे तो क्या आएगा? प्रॉपरली अगर लिखो तो ये हो जाएगा एनर्जी इज इक्वल्स टू n टाइम्स ऑफ hc by lambda डिवाइडेड बाय टाइम. हियर दिस इज द टर्म दैट यू आर डिफाइनिंग. इसको डायरेक्टली लिख लो n, और यहाँ h by lambda इज व्हाट योर चेंज इन मोमेंटम. तो ये डाउन डिनोमिनेटर में नहीं है, ये न्यूमरेटर में जाएगा. यहाँ पे गलती की है, और इसको डिफाइन कर लो समथिंग n. लेट्स डिफाइन इट समथिंग n. What is this h by lambda? It is equal to delta p, and here it is what? Power. Correct? Now if you want to calculate change in momentum will be what? It is equals to power divided by n into c. So just divide it by time, that is the force that you will be having. Force will be equals to, here also divide by time, power by time into n into c. n into c, this is what you will be defining as power. Now और पर सेकंड, अगर पर सेकंड कैलकुलेट करना है तो टाइम को कर लो 1. इफ यू वांट टू कैलकुलेट इट फॉर पर सेकंड, व्हाट विल बी डूइंग 1. नाउ फोर्स ऑन अ प्लेट ड्यू टू 1 फोटोन विल बी दिस मच, एंड टाइम को कर लो 1. इफ यू आर डूइंग टाइम per second, that means it will become 1. So what will be the force due to n number of photons? Due to number of photons, it will just multiply it n times of delta p by t is equals to power divided by c. ये आ जाएगा, correct. Now if you want to calculate pressure, what you will be doing? Divide the power, divide the force divided by area. If you want to calculate pressure will be defined as force per unit area. What is the total force that you are having? Total force is power divided by a into c. और पावर को क्या लिख सकते हैं? इंटेंसिटी इंटू एरिया डिवाइड बाई ए इंटू सी. ए हो जाएगा कैंसिल, और द फाइनल रिजल्ट दैट यू विल बी हैविंग इज आई बाई सी. द फाइनल रिजल्ट दैट फाइनली आफ्टर द डूइंग दिस मच ऑफ द थिंग्स दैट यू विल बी गेटिंग इज आई बाई सी. समझ आया? थोड़ा आया? खुद से करना है एक बार. गो स्टेप बाय स्टेप. आई हैव टू टेल यू ऑल द स्टेप्स सो दैट यू कैन बी सो अंडरस्टैंडिंग द थिंग्स फ्रॉम द कोर. Okay, otherwise I can tell you that just remember this is the direct formula, there is no problem into that, but understanding the thing from the complete basic, it is much better. इसी चक्कर में you also learned that how to write change in momentum. Okay, this is one extra thing that you have studied. So whenever you are studying it for the first time, at least try to do every single thing from your hand only. Okay, now let's see the second case also. Same method. Now this time only the change will be coming, that it is now complete reflection. Now no absorption is there, complete reflection. And so whatever it is incident, it is completely reflected back. Okay, here again I can say intensity is equals to power by area, that will be defined. Okay, लिखते हैं एक एक करके. What is the initial momentum? Initial momentum I will write minus of h by lambda. Final momentum, this time it will be reflected back also, and reflected back with the same completely reflection is there, that means I will write plus of h by lambda. So if someone asks me, tell me what is the change momentum, I will say this minus of this means I can say 2h by lambda. What I will say 2h by lambda. Energy incident per unit time, that means power. If someone asks me power I can write it is simply it is equals to intensity into area. अब define करते हैं main चीज. The main thing that we have to define is what? Number of photons incident per unit time. Number of photons, how we define? We write energy is equals to n times of hc by lambda, correct? N times of hc by lambda. Now divided by time, here also it divided by time, that means I will define it as capital N, that is what? Number of incident per unit time. And here it will become hc by lambda. इसको मल्टीप्लाई कर दो 2 से एंड डिवाइड कर दो 2 से, c by 2. This is what you will be doing. और यहाँ पे लिख दो power, it is nothing but power. Now see what are the changes that I am going to make. What is 2h by lambda? What is 2h by lambda? 2h by lambda is nothing but momentum, change in momentum. I will say n number of photons incident per second, it is in multiplied by change in momentum divided by c, multiplied by c, and here it is division, and there is 2. That means if I will ask you, tell me what is change in momentum and multiply it by n, because total force, if I finally I have to write, I will write here it as power into 2 power into c, 2 power into c. Any term that I am missing? No, fine. Now what is force? Force is for one photon it will be rate of change of momentum delta p by delta t, but for n number of photons I will divide just simply here t, here also it will become t, here also it will become t. And for per second, if I am to write, that means this t will be equals to 1, and what is the result that I am going to get? Force will be equals to 2p into c, correct? And here you will be getting, somewhere I am making any mistake, check it again. 2h by lambda I have taken here, and hc by lambda divided by t power, correct, equal to c, correct. So force you will be having 2p, correct. Now here you will be having, here it will be having 2 and here it will be having c, that means here you will be having 2p by c, 2p by c, that means force will be equal to net 2p by c. अब force आ गया 2p by c, that's why you have to write every single thing very properly, then only you will be having. Now radiation pressure is simply force divided by area. Force already you have calculated 2p by c into area, and power can be written as intensity into area divided by c into area, a cancel, that means it will be coming 2 intensity by a, 2 times of intensity divided by a. Is it clear? So what is the difference that in the result, if I will ask you difference, only single difference will be coming. In complete absorption the radiation pressure is I by c, and in complete reflection it is defined as 2I by c. Let's suppose 50% reflected, 50% absorbed, then just simply multiply half and half with both the results, simply you will be having your answer. So don't worry for the cases, let's suppose 30 or 70% will be there, then what will be happening? Okay, so these kind of cases you don't have to worry. See, simple question what is given here is the intensity of direct sunlight before it passes through the earth atmosphere. Intensity is given, कितना दे रखा है, इतना दे रखा है. If it is completely absorbed, that means what you can say, radiation pressure find करना है. How will be saying? It will be simply I by C. Simply calculate I by C. What is the answer coming? 4.7 into 10 power minus of 6 Newton meter per second. Option B will be coming. समझ आया? So what are the things that we have learned? We have seen about de Broglie. Lot of questions are there using conservation of momentum also in de Broglie. If good questions you are going to tackle out, so those kind of questions you can easily solve. Okay, now practice questions, in which we will have some question series also, so in that we will be practicing the questions. So this portion is now completed. Now we are entering into the modern physics only we are saying, but the next chapter, that is we are going to study about atomic physics, mostly comparable with the atomic structure that you have studied in chemistry. Lot of the things will be here also same. Okay, so that is what our next topic is. So until next time, keep learning, keep going with Tapasya, Endigu and then Digu Nama Tapasya.